And can I share my screen as well?
You should be able to.
It says host won't let you because he's just mean.
Yeah, well, that is me, isn't it? Okay, so how do I do that then?
I think I can see if we use Teams. We don't have these problems.
Okay, I could make you the host.
Co-host should be enough, I think.
Okay, I'll make you host, Todd.
Okay.
Okay, you are now the host.
Beautiful. So let's see. Let me stop my video for a sec, and I want to share my screen. Share screen. Aha. Share screen. Ah, that looks better.
Oh,
Can you see
geez.
screens?
I can see your screen.
Beautiful. God, so smooth. It's almost like I hadn't practiced this at all. All right.
Take it away, Todd. Thank you very much for agreeing to do this with us, mate. And you're going to take us through how to build a couple of things.
I am, and how to cut your fingers, obviously.
That goes without saying, mate. So
right.
Please go ahead.
Yes. And I'm going to start out with a disclaimer. Building DevOps devices for fun and profit. The profit clearly is not for you. It's for the people who sell all the electronic bits you will inevitably buy late at night when you have a really good idea for just that one more thing. So why are we here? So I think most of you guys know I really enjoy doing unusual projects. So I think a lot of people on this call might have seen my Commodore 64 DevOps one. My very first public demo I did was the bottom left there, where we hooked up a flight simulator and took data streams off it. This was even pre-IoT Hub existing, and did all kind of analytics and things on that. Built a AI-powered Stranger Things lights, and even a very useful Cylon detector that will use AI to detect whether or not the person next to you is a Cylon. So all things that could save your life. But there's always been a little bit of a hole in my life. And back in the early days of, even before the DevOps was DevOps, so there was continuous integration, and everyone had cool build lights. And I never had a build light. I never ever worked on a project. In those days, it wasn't an Amazon, so getting access to electronics was not as easy. And certainly there wasn't as much consumer-facing electronics. There was no Adafruit or any of these kind of things. So I always felt kind of sad that I never got one of those. And sure, you can run the little widget on your desktop and whatever, but it's not the same. So that's kind of how this started. And then at Ignite last year, I saw a great session by Martin Woodwards, who at that stage was the one of the program managers for Azure DevOps, but obviously with all the changes is now the director of developer relations at GitHub directly. And he did a great presentation, and I've got a link there to his repo. And you should definitely go and have a look, because on there he's got videos to the sessions and whatever. And he built this thing which he called DasDeployer, with sort of German efficiency. And basically what it is, it's a very, very fancy Raspberry Pi powered release button. So the idea is that, in Azure DevOps, one of its real strengths is the work it has around release management. So you can hook into other systems like ServiceNow, or send email approvals, or do whatever. But obviously that, I think the thesis of his demo here was that could be a little bit tricky for some managers. So they needed something big and shiny and blinky they could press, and that was the idea. I'm just seeing. Oh yeah, good, they're coming in. So that was great. So I thought, yeah, that sounds good. I want to build myself one of those, and he had a very cool demo and did that. So that's kind of where this journey started, and you can kind of see what he's got there. He's just got some nice little switches you can flip up and pick environments, some blinky lights, all good. Get back onto PowerPoint. So went and had a look at his repo, and he's got all the source code there. And then this is kind of the circuit diagram he had for controlling it. So I thought, yep, that looks, I can probably manage something simple as that. And off I kind of went on this journey. So of course, I'm a software developer, right? So you can't just follow instructions. That would be completely against the grain of what we stand for, right? We can't just take an architecture and do it. So I wanted to tweak this architecture. I wanted to do it a little differently for a few reasons. So one of the things on Martin's version, everything basically, the design is kind of hard coded. So everything goes to either to that little display controller we saw, or it goes directly to the Pi. Okay, so all the wires go everywhere. What I wanted to do was I wanted to kind of build a base system that I could then adapt and do different things with. So I wanted to control each of the elements of it in a kind of a modular way. I also wanted to abstract that connectivity because they physically go together. It also does limit, once you've got things in the box, it's really hard to get them out of the box or adjusted. So I needed to somehow manage the physical connectivity as well so that I could do that. The other thing, I wanted to learn more about the Pi because I'd built lots of little things with the Pi, but the Pi, as I found out, has a surprising number of different interfacing protocols and options. So I wanted to really kind of try out different ones. Even if I could do it all the one way, I didn't want to do that. I wanted to try the different ones. I also wanted to incorporate into it some hardware control. So the Pi can kind of simulate some of the things you got to do when you're interfacing with electronics, like pull-up resistors and all these kind of things. But I actually wanted to start learning how to do some of those in hardware as well. I wanted to have a go at prototyping from a hardware perspective, because we obviously, we iterate and do things in the software world. So I wanted to see how that worked in kind of a hardware world. And I didn't want to die, because this does involve plugging mains power into something. Yes, clearly I didn't die. I did get a few shocks along the way and learned some important lessons, but we'll kind of cover that. So that was kind of the goal, what I was trying to get out of doing this. So before we go into all the nitty gritty, let's have a look and see how this darn thing works. So let me jump out of here. Now, before I even do that, I've got to say, and I know it's a bit hard to be interactive on that, I am just loving VS Code, as I'm sure most people are. But let me tell you, VS Code for working on a Pi is awesome. So this is VS Code running on my PC, but you can see down here in the bottom, I'm remote connected into my Pi. So this code here is actually sitting on my Pi. I don't need to install anything on my PC. I've got a nice little terminal window here. I can come and work, do everything I need to do on the Pi without physically having to go on the Pi. Which, when your Pi is embedded in a machine with wires and whatever, is awesome. But it also means you can listen to your Spotify and do all your kind of cool things. So, got to say that was awesome. So I'm gonna have to, let me think about how I'm gonna do this. Let me switch over. Yeah, I can't really split screen this the way I wanted to do. That's okay. So what we're going to do, before we do anything else, let's jump over to, we're going to jump over to, okay, my Azure release pipeline. So I've got a deliberately, oh, let me get rid of that. Go away. So I've got a very deliberately simplistic release pipeline defined here in Azure DevOps. Once we load, you can see. So we have dev, and of course we go to staging and prod at the same time, because why wouldn't you? Mainly for demo purposes. And each of these stages, though, if I come and click in here, has an approval process. So at the moment, it's just got me as an approver. So what I'm going to do, I'm going to create a new release for this pipeline using the existing build, because the build's not really the issue here. And we're going to leave everything as manual approval, and we're going to create that. So then we can go and have a look at build 40. Oh, it's not build, release 43. Okay, so we can see here, here's our release pipeline. It's all good to go, but it's waiting on approval. Now, obviously I could just click on the button, but what on earth fun would that be? So what I'm going to do now is jump on over to my Pi, and I'm going to fire up DasDeployer. Well, I was calling it Retro Deployer because it's the whole retro thing, and so I didn't get confused when I was looking at code, whether I was looking at Martin's or my own. So we're just going to fire that up, and all being well, oh, I've got to be super quick. get over here, stop sharing, start video. Hopefully you can see, oh, I wasn't very quick. I don't know if you noticed, but the big light was red for a while. It was flashy, doing all kinds of things. Basically that was waiting on, it was syncing up to Azure DevOps. It was checking all the status of things. But because basically for this, we configure a couple of different things. One, we configure the build pipeline that drives the release. So the green light in the middle is basically the build status of the last build that drives this release. So because it passed, the middle light's green. If it was building, it would be flashing colors and different things. So that's kind of cool. Now, you can see up here now the lights we have, hopefully, oh yeah, it's in focus, I can see there. You can see our dev light here. Now, the way they're set at the moment, we can actually approve any of them, but we're gonna go dev, so we can see that here. I'm going to flick that switch up, which is going to enable, basically, it's ready to deploy. So now you can see it's got all red and ominousy, just to let the manager know that that the bad things could happen. But of course, I'm a manager, so I don't think about that kind of thing. So I push the button. I'm off and away. And this is where this is kind of hard, because I'd really like to split screen. And in theory, oh, okay. So the approval's been approved. Yeah, that was a little additional bit I added there. Wasn't in Martin's. If I can show this up to you. The manager gets a nice manager-friendly release. Oh, it's going to be hard to show. But you can see what the environment name we deployed to was. Oh, no, it's really hard to read, sorry. To dev, what release number it was, the ID, and barcodes. If you go and scan that, it'll tell you DevOps and the build release number. So there you go. That's all it does as a nice little manager thing. If I share my screen again, let's share this. And if we jump on over, hopefully to we can see here on the site, the build has been deployed, and I'll jump back over to the machine in a second. You'll see that the light for the dev side has kind of gone off. So that's pretty much all it does. It's a big blinky manager friendly light. But it's kind of fun. And it also does kind of put the highlight. I've often found, even when talking to customers, they think of DevOps as being fully automated. And whilst it certainly can be, it can easily incorporate, particularly with releases, these approval steps, right? And that it could be a blinky button. That approval step could be creating a ticket in ServiceNow that someone has to approve. That ticket could be anything, right? So, but once that step then happens, we come back here and we keep progressing. So that's kind of the idea. So I'll turn this off. And the great thing is I didn't even get an electric shock on it. So that's kind of awesome. So let me jump back over to, okay. Let me pause there. What I'm going to do now, so that's kind of the core functionality of DasDeployer. Okay, it's got the LCD, the buttons you can see. No, you can't, because I'm not sharing my webcam. Dear idea, Todd. Getting it together. Let me stop sharing for a tick. Let's go back over there. Okay, so yeah, so the buttons over here are for different kind of utility functions, if you like. So for example, if I want one of the problems with this, you might not be able to power it down. But if I hold this button down for 4 seconds, it'll go into a diagnostic mode, and I'll get things like CPU temperature, IP addresses, all the things I might need to know pop up over here. And then the plan, and then once you're in that mode, blue will get it out. If you hold it even further, it'll turn off. And the idea later on was I'm going to increase the functionality. So basically, these are your four little input buttons you can do things with, and you can differentiate between a press and a hold and all that kind of thing we'll get to. I've got up the top, it's very hard to do backwards. You can see I've got a little toggle switch up there for Azure DevOps and GitHub. So one of my next things will be to repeat this process for GitHub, so you can toggle between the two environments. So that's kind of the gist of what the machine does. So I'll switch back over to slides, but before I do that, let me pause. Is there any questions from a functionality or machine or whatever point of view?
I've got a question. How hard was it to actually, or what's the printer, and how hard was it to actually get that embedded and working?
I'll show you. I'll go through that. It was actually amazingly simple. That was one of the simplest things to get in. Yeah, no, it's literally, and not only that, it is so. If actually, I'm still on webcam. Yeah. Okay. So let me flip this up. He says with no fingernails. Grab. So this is it's just a thermal receipt printer. It's actually really hard to get this out, but there is no print head at all, right, in these things. So it just works off the heat from the 5 volts. And basically, these are from Adafruit, and there's different sizes you can get. And basically, yeah, it comes with a library. In fact, I'll literally show you the code. Hang on, let's do that. And yeah, it's crazy easy. And to generate there's libraries for barcodes, for QR codes, for images, all that kind of good stuff. So let me share my screen. We'll jump over another one. Share my screen. So I also wrote a whole bunch of little test programs so I could test each module of it, if you like. Test printer, except the printer got added late. So you'll see its test code is a little...
Oh, it's like mine.
Yeah. But all the other ones have it. Look, just to prove. So if I was to shut down DasDeployer, there, I can run these, and because I was testing, particularly when I kept tweaking with the hardware, I needed to have a known kind of state. But if I here we go. So here's the library code that actually prints that receipt. So I'll show you in a second as we go through. Basically, it's running off the serial port, right, at 19200 board. So basically 2 pins on the Pi are dedicated to running serial, and it uses those. And you can see it's just got this library of, commands, turn inverse on, print something, do something, justify stuff. And then when you get down to the bottom here, you can see print a barcode, it's print a bitmap image. It's literally that simple. It was crazy. Simple.
Wow. That's amazing.
So they're really nice. And the fact there's no print head or whatever, and the paper you can just buy at Officeworks, it's just standard receipt printer, Officeworks stuffy. So yeah, that probably took an hour to get going, and that was mostly just working out what these commands were. But yeah, no, that was pretty straightforward. So that's kind of where we got. So that was fine. Let me skip down here. So I'll show you again on the webcam in a sec. So this is kind of the process I went through. I kind of went again. Part of my thing was trying to think about how you do hardware prototyping. So this is foam board I've got from Officeworks. So I bought this and just kind of cut things up to work out, because I was changing the layout for Martin's because he doesn't have the printer. So I moved the button over here and I pushed things around and kind of just figured out where they would fit. So that was fine. Then I transferred it to Wood. I thought working in Wood would be easy, and drawing circles or drilling circles is really hard. Cutting a straight line inside a piece of wood with a jigsaw, I don't know. I'm just missing that gene, but it was incredibly difficult. But anyway, it was a good prototyping step, and that was so we got that. So yeah, and then I went to I had obviously the plexiglass laser cut, and I very carefully measured everything 20 times, and I only got about 4 things completely wrong somehow. I'll show you those in a sec. Well, I was actually surprised, particularly for things like the LCD, because they've got mount, you got to think about the mount holes as well as the thing. And there's obviously in acrylic, you can't just kind of sand a bit off. So yeah, I was actually quite amazed it worked as well as it did. So here's a Raspberry Pi, right? Everyone's seen one of these, and the GPIO pins obviously are the power of it. But there's actually a tremendous amount from a software, something about a software and a hardware point of view. There's tons of different functionality in here, right? So if you think of this thing rotated clockwise up is what we end up with. And they're not just pins, right? There's some pins which are just general, these GPIO pins, but there's other ones that have 2 or 3 functions, right? So that's kind of had to learn about those a little bit. So for example, if you just think about the how to get power into and out of the Pi, there's all sorts of different things, right? There's a whole bunch of ground pins, which are all connected. Doesn't matter which one you use, but you need to think about the ground pins. But then there's also, obviously, there's 3.3 volts out. And then there's also 2 5-volt out. So you can draw some current there for 5-volt, not very much. So we'll get into that. So yeah, really had to think about power, because for the switches and LEDs, they don't need much power at all. They don't need much. But once you get to those lights, especially the LEDs, one of them doesn't draw much, but there's 40 odd altogether in that, and they start to draw a lot of power. So you can't power those from the Pi. Yeah, so for things like switches, so the toggle switches and the push button switches, basically they could just connect up wherever you wanted to, and these are kind of all the options. These are these standard pins. The biggest challenge was trying to work out, logical groups of them. So for example, this obviously has 3, I need 3 switches for this, but then I also need 3 pins to control the light. So that's 6 pins. So where's somewhere where there's kind of 6 pins relatively close together so that, your wiring doesn't go all kind of crazy. So that was standard ones. It also has an I2C circuit. So this is IIC. So this is a serial protocol that you can use. And the great thing with this is you can chain them along together, because each device has an address. And if you have a look, so this is actually what the back of the LCD display looks like. The big one at the bottom is the LCD. And if you wanted to hook it up directly to the Pi, you'd have to use all these pins at the bottom, which is a lot of pins, right? But because what they've done, they've added this I2C backpack and these ICs here, it takes care of all of that. So now you only have to worry about these 4, power, ground, and these 2 data pins, which are the data and the clock, these BCM 2 and 3. And then I could chain, any number of devices along the line, and they have different addresses, and then they come with these kind of solder pads. So if I wanted to change what address this was using, because someone else already used it, I could just drop a blob of solder to short this one out, and that would change the address. So I can have multiple addresses on each one. So that makes life much easier than having to connect all these, because if I was to connect all these pins, you'd pretty much use all the available pins on the Pi just to do that one device. We talked about the printer. So yeah, so it actually works off a really old serial protocol. And so really the actual power and ground actually don't come from the Pi. They come directly from the 5-volt source, because they actually draw a lot of power. And the more power you have, the darker it is. So the only 2 pins we need to connect to the Pi are the transmit and receive. So it's the old serial transmit receive type ones. So the power itself, so on Martin's one, his switches he used for those multi-purpose switches were actually 12-volt switches. And as a result, he used this power supply, which had both 12-volt and 5-volt. I didn't want to do that, so I switched mine out. I'll show you in a sec, for just lower power switches, which means I could get a different one of these Meanwell power supplies, which was smaller. Only did 5-volt, but it put out 10 amps as opposed to 10. So these things are very cool, quite cheap and quite small. Yeah, and it does mean that if and when this was Martin's slide, right? But TSA friendly, remember when we had to worry about stuff like that? Wasn't that nice? So here's my beautifully laid out modular design. And this is where I learned probably my first lesson. And I guess there's some interesting parallels with software here, right? Should I microservice or should I not? The modular approach was really good because it simplified some things, and it also made other things incredibly complicated, not unlike microservices. So if you have a look up in the top left of the image here, this is the power supply. It's not plugged in right now. Those empty sockets are where the mains come in, but here's the plus and minus 5 volts coming off here. And what I end up doing is coming over and running some little distribution buses over here. I found a really cool, funky little distribution board with fuses and whatever, but it was like 5 centimeters high. And I'll show you at the end, when you install this in the case like Martin did, but you don't have much height to work with, and you got to worry about the height of the things coming down. So that comes over to here, and then you can see it breaks off there. It comes over to, oh, it's actually not in this picture, but anyway, they're over here. You can see in the left here, here's my little barrel jacks. So one of those goes over to the Pi, one of those comes over to this thing, which we'll talk about in a sec. So this way I can tap off more power here, because I also want to have more LED matrices on here, so that'll need a lot of power. So that's but you can see, and the funny thing, it took an hour to figure out and get the code and everything running on the printer. to find these little leggy things to stick the things on the board, my God, that took weeks. Like to work out what the hell these are called, right? Because they're not standoffs, because I'm going onto wood here, and trying to find all the widgets and doodads and little bits probably took the longest part of this whole project.
So I assume JCar was your friend in this, yeah?
No, JCard.
Oh.
So no, for some stuff, yeah. Stuff like this, no, they don't have. So this was
Wow.
like, this was hours of searching on Amazon. See, the problem is I don't know what they're called, right?
Okay.
They're not standoffs. Once you find what they're called, it's easy to find. So most of these were like orders on Amazon, but then they took weeks and weeks. And even then, I'm still not super happy because you can see how tall they are, right? So what that means is that really adds another 3 or 4 centimeters to the height of the components, which I'd rather not have. But at the moment, it's not an issue. So imagine there's a photo of the height there. So the way I built this, again, wanting to prototype. So I started building the circuits on breadboards because I was learning about the electronics as well. And the reason I did that, and then there's another type of thing called a perma-proto board, which uses the exact same layout, but you can actually solder to them. So the idea of this was, so the way these both work is, if you haven't done this electronics before, that these top 2 lines are connected across this top. So you can see here, they're all connected. So if you put, this would be your positive power, your negative power, for example, whereas these columns are connected, okay, but there is the gap in the middle. So that gives you a lot of power. So we'll see in a sec, things like, this is exactly the right height, so you can install integrated circuits and things across this gap. But it was handy being able to prototype it on a breadboard, and then without having to redesign it for like a standalone circuit, just move it literally onto a perma proto board. And that's kind of what the prototyping looked like, right? So you could do it here. You could see here, this is a little logic level converter. We'll get to in a sec, but yeah. So it made the prototyping part super, super easy. And you can see how tidy I keep my work desk, and you might understand why I did get a few electric shocks, but that's a different story. But yeah, once you've done the prototyping, then you can move it into something like this, which is more permanent and soldered in. So that was all pretty straightforward. So I did switch out the buttons, as I mentioned. So these are effectively 2 different things. So they're a switch and an LED completely separately. They're not connected. So the top 2 are the LED and the bottom 2 are the switch. And after I learned another lesson, don't order the number of parts you need, because you will lose, break, kill something. One of the first things I learned was these don't have an LED, a resistor to protect them. So as soon as I plugged it in, I blew the LED, and you can't replace it. And I had to wait 3 weeks for another one. That wasn't so much fun. So yeah, those 2, just basically a little LED. So that's how I built it. So I would build, okay, I've learned that lesson. So I'm going to connect up, say, those buttons. I design it up in fritzing, connect those up, put in some resistors to protect the LEDs this time, and all good. Okay, that's kind of and then for the buttons, because they've got the 2 functions, similar kind of thing. And then I would go off and build my little modular board. So this was the board that just handles the 4 buttons. So the way it works here is on the left is the LEDs. So each of these goes to those 2 LED pins, and these 4 other buttons go off to the buttons on it, and just connect up like that. So again, I wanted this to be modular, right? I can pull these are not soldered on. I can pull them off. This is a fairly standard size hole. I could switch these out for different buttons. I was really looking for some square ones, but I couldn't find any I really liked. So, but again, it's that idea of trying to keep it modular. The other thing that Martin called out, and it was I'm glad he did. Normally when you program code for the Pi, you write stuff like on the left here, like you control the pins, you tell it a pin number, you tell it to do something. So it's really low level, right? And then when you want to check to see if a button's been pushed, you got to basically be in an infinite loop going, is it pushed yet? Is it pushed yet? Is it pushed yet? So by the time this thing is built, I have no idea. There's probably 20 or 30 different inputs you would need to check every time, and be a nightmare of a code. But there's this fantastic library called GPI0, and literally it does a whole ton of stuff, right? Particularly it lets you, it adds in a whole event-driven model. It abstracts away a lot of the lower level electronics, so you can do things very easily. and I don't think I got time to add it. I didn't. But the other cool thing, I'll show you the code in a bit. It lets you define composite controls. So, for example, it has a thing. It has an idea of a button and an LED, but you can define a button LED, and you basically put them together. And then I can define a button board, which was all those 4 buttons were one logical thing, and I'll show you in the code later. You can just refer to that. So there's a great library for abstracting away a lot of the hardware stuff. The toggle switches were pretty much the same as the push buttons. They're even easier because they're just running off the 3 volts from the power supply. So basically, I just created a simple connector. That's pretty straightforward. These are actually from marine. These are for sort of marine use. So the recommended rating is 12 volts, and they're absolutely blinding. Even at 5 volts, they're super blinding. So I just run them off the 3.3 volt from the Pi, and even in daylight, that was plenty of light. Cool. Had to figure out the switches. So these are the back of the toggle switches, because they're designed always to, the LEDs are designed to be on all the time, because in a car or a boat, you'd want the light to be on if it's on. So instead of that, we basically, this bottom pin is the ground pin, and then we use this top pin here. If you want to turn the light on, you supply some power to it you basically pull the line high on the Pi and it turns the light on. And if they toggle the switch, that bottom one there sends a signal back to the Pi. The LCD display we talked about. The great thing was there wasn't a Python library for it, but Martin wrote one. So yeah, I just used his library. And again, pretty straightforward, write text, not much. Again, though, needed to be powered by 5 volts. So this didn't come off the Pi. This came off its own, directly off the power supply. And of course, the most exciting part, the big button. So this is actually a arcade switch. Big switch. So basically, at the bottom of it here, it's just a little micro switch. That's all it does. And at the top, it doesn't look anything like what you saw. It's just an LED. So basically, hang on, let me come back. Basically, what is inside that button? You can see again my incredible workmanship. I bought a Dremel. This is the first day and the last day I used the Dremel. They are the work of the devil. But anyway, so this is a series of, this is basically some NeoPixels or little RGB LEDs. And so I just, kind of put a small circle there in, fed some cables out, and then I've got another circle that goes around the outside, and each of these has a data in and a data out. So you can chain these together as much as you like. So that's what you're seeing here. And as long as you supply power, and you can supply power kind of all on the line, you can actually stretch these out crazy far, right? But for us, only doing 32. But as you saw, right, they have amazing sort of color depth and control, and color libraries are very cool. You can do all sorts of fun effects. So that was all good. So really the last problem to solve was because all the buttons worked off 3 volts, but controlling the NeoPixels, for example, doesn't. It works off 5 volt logic, not 3 volt logic. So we needed to somehow convert, because even though the Raspberry Pi is powered by 5 volts, it actually uses logic level of 3 volts on its logic line. So we needed to somehow convert those, and that was pretty straightforward. You can buy these snazzy little Ttl converters. So basically one side, it's a bit hard to see in the photo, you can see up the end here, it says HV1. So you plug 5 volts and ground on this side, and then your data pins here, your 3.3 volts and ground on the other side, and these magic little chips just translate one to the other. So, and they're bidirectional, so you can go back and forth and talk 3.3 to 5 volts. So they're kind of handy, super cheap. So here's the controller. So if you remember Martin's diagram before, here's my version basically of that. So everything above the red line is low voltage. So this is the 3.3 volt side that goes to the Pi. I've also added some pull-up resistors. Remember I said I wanted to do some of the hardware control. So that would make sure that if the button's not pushed, that it's held high. So you don't get noise on the electronics going up and down. And everything below here is the 5 volt side. So there'd be 5 volt power, a bit of a capacitor to provide protection, a resistor to protect the data pin, and then the red, white, green go out to the matrix displays, and these two just go out to the micro switch at the bottom. And this horrible bit, see this little bit here? Yeah, that was going to be my button switch that you saw on an earlier board. And I was trying to cram it in. I was trying to make it fit, and it didn't fit. It was never going to fit. It was a stupid idea to try, but you know, I tried, so that does nothing. But I guess that's part of the prototyping process. You learn those lessons. Printer, we've kind of already spoken about, right? Just does receive, transmit. Yeah, that was super easy. I love that one. That was good. The only catch with this was I had, again, one of the reasons I had to rejig. There's something wrong. These don't work with the Pi 4. There is something wrong, or not wrong. There's something different on the Pi 4 in terms of how it does serial. That at the moment these don't work. So I had to switch my Pi out to be a Pi 3. So that's pretty much all the hardware, right? So then the only thing we've got to do now is actually talk to Azure Pipelines. Now, that's reasonably easy. Martin wrote some great code, which I used. The only catch was there's been breaking changes to the SDK between now and then, and that took me a little while to figure out. But the library itself is pretty straightforward, right? You just create a connection using a personal access token, and in our case, basically just say, give me a list of all the approvals, which are deployment approvals, because you can have other sorts of approvals. And then once you press the button, it'll go off and do the, it's kind of that simple. Yeah, and pretty much the only config we need to do is, you know, just tell it what DevOps URL, what the pat is, what project, which pipeline you want to monitor. So that's the in the big button, that's the build status, if you like. So that button is effectively the build light I always wanted. And then the release ID that the approvals work for. Whoops. And then this is kind of, I guess, hard coded to only be able to support up to 3 environments, but you can control which environments. These are the IDs in Azure DevOps that relate to those environments. So that was the first one. So that was good, and it was a lot of fun. I learned a lot. It took a lot because I needed to learn a lot, and it also took a lot because just ordering parts took forever. Like when I blew that LED push button switch, it took 5 months to get another one, because basically all the stock comes from China. No one has any stock, and yeah, just there were other priorities at the time, which is fair enough. But yes, it certainly makes prototyping a difficult concept. So I was going to say one other thing on that one. So yes, before I do that, that's okay. So now I wanted to do something for GitHub, because, you know, we're all about the love and sharing the family. So I haven't done a lot with GitHub Actions. So again, this is still early stages, but I wanted to at least get something working and look at how I can interface with GitHub Actions. So not necessarily the releases, but just what could I do? So I had a bit of a play around with it, looked pretty good. So I could see how I could create the action. I see how I could hook into something, but then it was a question of, well, what am I going to hook into? Because the problem is with this kind of device, I didn't want it necessarily sitting there directly connected polling. I didn't want to expose an endpoint that it was going to send it to. So I needed to send it somewhere. So the obvious choice to me was to use something like Azure Event Grid, because, you know, it's an eventing platform and I want to monitor events in GitHub. So obviously Event Grid has connections and events hooked in for all the Azure service, but it also has this concept of custom events. So basically an endpoint, anything you want. So that's what I'm going to use. So I'm going to hook GitHub Actions up, pass through the event in GitHub to there, to Event Grid. And then I can have all sorts of things hanging off the back of that. These event handlers can come in and subscribe to that event happening. So in this particular case, in the first example, I used a webhook, which I'll show you in a sec. So basically I run a web API that gets called by Event Grid whenever an event, and then just a web app that shows it. And then there's an interesting tale I'll tell you about my other device, which actually used Service Bus just for simplicity. So we're going to end up with, in our scenario, one going to there and one going to there. So basically, this is what we're going to see. So have our GitHub repo, and at the moment, this is all very basic. So just either off a push or a pull request fires off an action. And really all that action does is build up a payload of information about the action and do a HTTP post down to Event Grid. So I've got a topic called something like GitHub events or something very creative. And then the 2 different services both subscribe to that event. And if you want to, these subscriptions can have filters and rules and all kinds of things. But at the moment, I just let everything go through. One will put messages onto a service bus, which is then going to be pulled down by the Pi and display on another RGB. And as I said, the other one's going to webhook. And we're going to go to the web app. So, oh, no, go there, go there. Let me get out of here. Let's jump over to GitHub. Not there, here. So here's the repo for my Commodore 64 website. So wasn't doing anything. So I added a workflow into here. And as you can see, it screams, I just wrote my first workflow. So basically you can see here, all it does, if on the master branch, we get a push or a pull request of any of those sorts on the master branch, then fire off this GitHub action. Does some filtering, but really ignore all this stuff. The bit it actually does down here, because at the end of the day, all it's going to do is a post. Why am I looking at the wrong thing? I apologize, that's the wrong workflow. Wrong repo. That publishes the static site. Blah, 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 blah. It is this one. That looks better. Okay, thought I was going mad. Yeah, so yes, basically just a push or a pull request with not any filtering. And then all I do, just as a kind of proof of concept here, I pull out the GitHub actions, what do I call it, framework, platform, exposes a whole lot of properties. So in this case, I pull out, the author that triggered that, put that in some variables, and basically build up a payload with the right thing. And all I do is curl. I just post it with the key there. There's not currently, doesn't seem to be anything in the marketplace in GitHub Actions for Event Grid. So that might be next week's project. But right now I'm just treating it as a HTTP endpoint, and away I go. So let's see that in action. Let's come back. And actually, one thing I did like is that because the workflow is in GitHub, when you change the workflow, it triggers the workflow that the workflow is workflowing. So I actually didn't need to do any tests, which was kind of interesting. So I could, for example, come in here. So, before I do that, so I'm just using there's a sample site on the Azure samples that basically just views things to an event grid. So that's what we've got here. So you can see nothing up my sleeve there. Yeah, am I in edit mode? I am. Okay, let me just make a super important change to do that. We'll commit that. Okay, so in theory, that should have triggered my GitHub Actions, which is actioning away and doing the almost nothing that it does. So yeah, it should be pretty much done. So if all being well, hey, there we go. So now this, of the two paths that you saw, this one is coming from the webhook. So Event Grid has called our event hook, and you can see here's just the bits of some metadata I sent through about the event. That's kind of the one flow. Here's where my tail gets a little sad. Let's flick back over. Actually, no, we'll go back to the slides. So here is the part where I now show you the gadget that goes with this. Now, if we were doing this session last night, it would work. If we were doing it at 7 o'clock this morning, it would have worked. But since we're doing it now, it looks like this. You can see those little boxes there. That's where it should be scrolling all that great info. That's all the info it's getting from Service Bus with all the author and all those useful things. So why isn't it working? Have I mentioned I don't like Python? So at 8 o'clock this morning, I was testing something. I was reading about something and I thought I'll add this one feature, and it said, yes, but you need to update this Python library. I don't like Python. I actually like the language. I don't like the Python. Somehow I've completely screwed up the Python dependencies. And unfortunately, this matrix is very sensitive to timing and all sorts of things. So you're just going to have to trust me that what those blocks represent there is that exact same message we saw on the website. Does anyone?
I think there's a lesson there, isn't there, Todd? Don't make last-minute changes to production code.
Oh, there's many, many lessons. And, you know, if it was just my code, it would have been fine. But it was, yeah, I spent 3 hours this morning just trying to unravel that dependency. Yeah, just didn't happen. So unfortunately, I apologize. But that, you get the idea. The service bus messages anyway, it's literally the same thing. So this one is very early prototype still. So again, I've got my build lights because now we can do those. So when, you know, when a build is complete and green like it was you saw, so at least that bit's working. But yeah, I had all sorts of funky graphics and cool stuff there. And now even the basic, you know, the built-in demos don't even work. But, you know, my Altair works, so that's okay. Bloody Python. So those were my two gadgets. So certainly in terms of kind of why I set out to do this, you know, I definitely learned a lot. I didn't die. That was handy. I did electrocute myself a couple of times because actually let me switch back to the webcam because I will show you that before we finish. Zoom. Oh, I'm already here. Okay, so now if I can turn this around, oh, there's a couple of things I'll show you just because they irritate me. It's probably hard to see, but most things are really nice. This thing here, I kind of designed this up by hand to send off for laser cutting, and look at that, it's perfect. This printer, that lip on the printer only has about a 2 mil overhang, and it's perfect. The toggle switches that I spent 8 hours measuring, not even close. I don't understand. The top, perfect. The bottom, the hole isn't right. The things that, the problem is that it's not just the size of the panel. The actual toggle switches stick out underneath. So you need it. Yeah, anyway, it went horribly wrong. But if I turn the, how am I going to do this without killing myself? Here we go. I'll try and turn this around. Because again, this is designed to be mounted in that case, as you saw, right? So you, oh, yeah, you can, oh no, yeah, I'm backwards, I know. Okay, so you can kind of see below here, you can see the power supply down in here. And you need one of these little connectory doohickeys to connect your power to, obviously. Now, before I didn't have this piece of wood and that was just kind of dangling on my desk. And yeah, you tend to collect little screws and all sorts of things when you're building this stuff. And yeah, it hurt a lot.
One assumes you've got trip out switches in your house, yeah?
I do, and that thing's got a fuse in it. Yeah, no,
right.
Lots of good. It still hurts though. Yes, the swip twitch. But anyway, so I learned that lesson. And the other thing, I sent Martin Woodward a photo of this. Hang on, let me turn it back this way. Okay. When I was designing the text at the top, you know, I had to make sure, because the way it laser cuts, it was hard to get the font size right. And I was paranoid about getting GitHub wrong, right? The capitalization of GitHub, completely ignoring the fact that I got the capitalization of Azure DevOps wrong.
Yeah, but which one's more important, mate? I mean,
well, the funny thing, I didn't notice, and I sent Martin a photo. He said, "That looks awesome. Do you know you've spelled DevOps wrong?" I went, "Oh, crap. Thanks for that. You could have just let that one go." Anyway, I'll have to get another one made to fix this, so I'll fix that at the same time. Yes. Sure. Actually, while I've got it there, let me just show you this. We're pretty much coming up on time. I'm just going to run.
So how much fun was it actually doing this, though? It must have, it was a ton of fun.
It was a huge amount of fun. The biggest challenge was because of COVID, and you know, this is I was doing this when kids were home, whatever. I'd only get bursts of time, like an hour here or there, and often it would take me 45 minutes to get it out of the cupboard and get all the gear set up, and then you get 15 minutes and have to stop, and then you got to come back and try and remember again, what the hell was I doing, and all these kind of things. So that kind of made it a lot harder. But it was super fun. I loved learning about the electronic stuff, you know, because I want to do some more IoT stuff, and learning about all these different protocols and things was super cool. So there we are. I'll put that on. So that give you a bit better idea of, yeah, some of the you can say now you can see in there, you can see that little ring kind of highlighting, and it basically is just one long matrix. You can do all sorts of funky things. So, and the other LED matrix on the other thing is not that at all, right? They're just dumb pixels. So it basically has to bit bash all those. These things being individually addressable and whatever, you can do some very, very cool things. So I've got some other cool ideas to do with those.
So I will say it's a bit of a step up from my build thing that I did ages ago.
I remember seeing that. Yeah.
Yeah, it was Codify. Ben from Codify. They did the spreadboard.
That's right.
Yeah. Unfortunately, the SD card for it snapped in half, so I've lost it.
Oh no. Well, and look, the thing is, you don't have to do this either, right? The other thing, there are some standard kind of fittings like Grove and things like that where they've defined standards. But I guess I deliberately wanted to, you know,
You've pushed the envelope.
I wanted to learn about the electronics, right? That was kind of the idea. Particularly because the next thing is obviously I want to hook this up to the Commodore 64. So I need to use that serial RS-232 style protocol to talk to that. So that was yeah, I want to do that. So let me just show that. So that was all good. Come on, go maximum. There we go. So that was all good. Yes, lessons learned. Oh yeah, you can't see it. It's a bit hard to see on here, but the height you're seeing here is not the height in the case, right? The height you've got if you mount this in the case is about only a little over half of this. So it's really difficult to get the electronics coming down, like the push button, not to hit something. So when you're planning this stuff out, that was the one thing I planned it out in 2D. You know, I drew the top thing and I drew the bottom thing and then went, oh, look, yeah, there's a third dimension. I didn't think about that. Yeah, Python sucks. Yeah, and I think I'm very excited to start learning about GitHub Actions. I think it is very different, right? Although, you know, it's built on pipelines, so from that point of view, but it's more about, you know, the model it uses for how it gives you info into the events and all that is very different. So I'm excited to kind of learn about that. As I said, Martin Woodward has an awesome repo. I need to finish mine and tidy mine before I publish mine up because I don't want people to hurt themselves. But his is super good, and there's links there to his video, and it's super awesome. And that's it. Thanks very much.
Mate, Todd, thank you so much. That was really, really cool. Are there any questions from anyone? Anyone want to chime in? No, probably not. Mate, seriously, I know what you mean about the power thing, right? Because when I was doing this with Anthony, he said, now, be very bloody careful when you do this bit here, right? Because that's that's the power coming in. You don't want to stuff that one up.
No, and even silly things like the connector that you plug the mains into, it's got blue, red, and yellow coming out the back. It doesn't tell you what blue, red, and yellow is. Different people use different colors. You can't just assume that because it's red, it's the positive. You got to check everything.
Yeah, so I thought there was a standard for that around the place, but obviously not everyone follows it.
Well, no, but it's different in different countries, and you don't know if you don't know where your part came from.
China, I'd say, surely.
Well, probably, but what country were they making them for? So basically, I ended up taking the approach that I tested every wire to make sure I knew what was connected to what. It was, especially when you got to wait 6 weeks for a replacement part. You know, it's just not.
Yeah, that's brutal, eh? Well, if there aren't any other questions, I'll let Todd go because we're bang on time.
Perfect.
So what are the little plastic legs actually called?
Good question.
I'll have to come back to you on that. I'll tell you what. I have another solution, and again, just to prove that I'm not, you know. Well, no, I was going to say prove I'm not insane, but that certainly doesn't prove that.
You certainly are.
So I found a better option. I haven't had time to try it yet. Okay, let's see if I can hold these up. We can see these little kind of luggy things. Basically, what they are internally is.
Are they the spaces that they use for motherboards?
No. So basically, you drill a hole, hammer that in, and then it's got like a little internal M3 slot. Now, if I've just described that to you, I've shown that to you. What are they called? Who wants to have a guess?
Riser lugs.
No. If you search that, you'll enjoy it. They are countersunk nut certs. So
That's awesome.
that's your word for the day.
Nuts, nut. What?
You need to somehow find a way to insert the word nutsert into a sentence
Nutsert.
at some point over the weekend. So
Nutsert.
But my theory is,
Easy. Todd, where did you buy your nutserts?
at the nutsert shop, obviously.
Oh, there you go. Yeah, I just did a search for it. Nutserts. Yeah, there you go.
There you go.
Yeah, something new every day.
Exactly.
Oh dear. Thanks once again, Todd. Really appreciate you putting that together for us, mate. That was really awesome.
My pleasure. Thanks very much, guys.
No worries. And stand by for the next one. Don't know when it'll be. And I'm going to see if I can grab someone from GitHub to actually give us a talk on something. So I'll have a chat with Anthony about that. Hopefully by the middle of next month. For those that came, thank you very, very much for coming along. And this will be up on our YouTube channel probably by the end of the day. So if you wanted to have a look at the recording. Other than that, you guys have a fantastic weekend and we'll see you all next time.
See ya.